Today in class we did a 10 problem unit circle quiz. It says test, but it's not really a test. Anyway, it was just 10 problems that are angles that are unit circle values and asking for the cosine, secant, tangent, whatever of those angles. And the idea is to be able to do this relatively quickly and not necessarily have to draw the entire unit circle every time. So I just wanted to talk you through a few things about how I do this and what it helps to know. Now, certainly you're welcome to draw the entire unit circle. It might slow you down though. And what I'm about to show you are things it really will help you to understand. Okay, so first off, it's actually a gift that these are in radians, because radians actually end up being a little bit easier in some ways to remember where they are and to figure out if you understand them. So once you understand what's going on with radians, it can help a lot. First off, we've got, with radians, remember that this is 1 pi over here. So over here, this is 1 pi. And so if I wanted to break this up into, for instance, thirds, I could take 180 or pi and divide it by 3, and every 60 degrees, that's 1/3 of 180 or 1/3 of pi. Okay, so the thirds are here and here. This is 1/3 of pi, this is 2/3 of pi. But I can also break that up a little bit farther into increments of 30 degrees. And 30 out of 180 is 1/6. So let's look at this in terms of sixths. We've got, this is 1/6 of pi. This is 2/6 of pi. 2/6 is the same as 1/3. This is 3/6, same as 1/2. 4/6, which is the same as 2/3. 5/6. Here's 6/6. Okay? So going on around, basically everything except, everything, literally, except the lines that are right in the middle of each quadrant, these right here. Everything except those can be thought of as being out of 6, a sixth. Okay, so 1/6, 2/6, 3/6, 4/6, 5/6, 6/6 is the same as 1. 7/6, 8/6, 9/6, 10/6, 11/6, 12/6 is the same as 2. Okay, so that's one way to look at this. Now, everything that's in that group, every single one of those, except, well, every single one of those that makes a triangle, every single one of those that's not on an axis, okay, because we don't need a triangle for 90 degrees, which is pi over 2, or 180, which is pi, or 270, which is 3 pi over 2, same thing as 1.5 pi. We don't need triangles for those. We can't make triangles for those. But all of the ones we can make triangles for, all of them are going to be either a 30, 60, 90, well, excuse me, they're not going to be a 30 either. They're going to be a 30, 60, 90 triangle. All of those. It's either a 30, 60, 90 triangle turned like that, or it's the same triangle turned like this instead. Okay? So we either have the triangle turned like this, where the 30-degree angle is here, or the 60 here, which is basically saying either we have a reference angle of 30. So let's see if I can, I'll do this one upside down. This has a reference angle of 30 or a reference angle of 60. Whoops. Here's the 30. Here's the 60. Okay? So every single one of those that you can make a triangle for is a reference angle of 30 or 60. So we've got basically the ones that are closer to the x-axis. Okay? Those are the ones where the 30 is the reference angle. Where if I draw my triangle, the x part is the longer leg. It goes out farther and then up less. Same thing here. If it went down, out farther and then down, or out farther over here and then up the shorter side. We're talking about the two legs, longer leg, shorter leg, longer leg, shorter leg. All of those are 30-degree reference angles. All of those are the same coordinates, just different signs. All of them, longer leg is the x value, that's the square root of 3 over 2. Shorter leg is the y value, that's the 1/2. So like this one is longer leg to the left, shorter leg down. So negative square root of 3 over 2, negative 1/2. Those are all the ones that are closest to the x-axis. Those are all the ones with a reference angle of 30 degrees, which is the same as pi over 6. Then we've got these other ones that have the reference angle of 60 degrees. Okay, this time the triangle is turned the other way so that the shorter leg is the x value and the longer leg is the y value. That's why it's the same coordinates, just switch places. So shorter leg first, so that's 1/2. Longer leg second, so that's square root of 3 over 2. And it works that way for anything that has that 60-degree reference angle. Like for instance this one right here, that's the 60. This is shorter leg is 1/2, down longer leg, so we get this. Okay, so the key thing in doing any of these, if I'm going to find the cosine, sine, secant, any of them, is figuring out the coordinates of the point. So for instance, number 1 here, cosine of 5 pi over 3. First I got to think about where 5 pi over 3 is. Well, here's 1/3, 2/3. The thirds, the ones over 3, are the ones that are farther away from the x-axis out of those 2 dots that don't include the 45s, don't include the fourths. So this is the farther away, farther away. This is 1/3, 2/3, 3/3. This would be 4/3. This would be 5/3. So we're talking about this triangle right here. Okay? The x value is the shorter leg, so that's 1/2. 1/2 to the right, down square root of 3 over 2, so it's 1/2 negative square root of 3 over 2. So on my paper, if I'm doing this problem, that's what I'm going to write over to the side. As soon as I figure out where that is, I'm going to write the coordinates of that point over to the side. Okay? Now, we'll come back to this and finish the problem, but I just want to talk this through on another one. Let's look at, how about sine of 5 pi over 6? Okay? 5 pi over 6. Now the sixths are the ones that are closer to the x's. So this is 1/6, which is 1/6 with pi over 6. This is 2/6, but it doesn't end up being 2/6. It becomes 1/3. This is over 6, doesn't end up being over 6. That's pi over 2, 2 pi over 3. Here's 5/6. So 5/6 is closer to the x-axis, so it means I'll go out to the left farther and up less. So in other words, the x value is the bigger number, the y value is the smaller number. So this is the square root of 3 over 2 here, this is the 1/2. So my coordinates are negative square root of 3 over 2, positive 1/2. So I'm going to come over to the side from that point and say negative square root of 3 over 2, 1/2. Now, do I use a new unit circle template every single time I do one? Absolutely not. I usually just sketch it. So let's think about the next one on here is 11 pi over 6. 11 pi over 6, I think, well, that's almost all the way around. That's almost 12 pi over 6. So it's the one that's just a little bit shy. You don't have to draw the circle, but it's got a longer side here and it's just a little bit down from 2 pi. This is 11 pi over 6. And this is square root of 3 over 2. It's the longer direction first and the shorter direction. Okay, so the x is the longer side, the y is the shorter side, so my coordinates are square root of 3 over 2, negative 1/2. So that's what I would put next to my 11 pi over 6. And so on. This is what I do every single time. Now let's look at a couple of these other ones, the fourths, for instance. Well, let's see. I think I may have used up all my pretty unit circles. How about I'll put it on here? All right, fourths are the ones that are in the middle of each quadrant. This is a fourth. This is a fourth. This is a fourth. This is a fourth. 1/4, which is pi over 4. 2/4 is the same thing as 1/2, so that's not really going to end up looking like a fourth. 3/4. 4/4 is the same as 1. 5/4. 6/4 is the same as 3/2. 7/4. Okay, so 3/4, 1, 2, 3/4 is the 45, 45, 90 that is in the second quadrant. The fourths are always 45, 45, 90 triangles. So the two legs are always both square root of 2 over 2. The only thing that changes is the signs. So you just have to figure out, well, I'm going to the left and then up. That's negative square root of 2 over 2, positive square root of 2 over 2. If it was down here, it would be negative, negative. Over here, it would be positive, negative. Here, it's positive, positive. Okay, so 3 pi over 4, those are my coordinates. Negative root 2 over 2, positive root 2 over 2. For number 5 here, negative pi over 2. Negative means go this way. Pi over 2 is 1/2 of pi, which is the same as 90 degrees. So that's this point right here, 0, negative 1. So that's what I write out to the side, 0, negative 1. Okay, number 6, since I've told you I don't use a unit circle, I'm not going to use a unit circle for the rest of these. I was just trying to give you the visual, because part of why I don't use a unit circle is because I've done it enough times with a unit circle and I've worked with them enough that I kind of see it in my head. And you'll be able to too after you've done these well. 2 pi over 3, that's 2/3 of pi. So that's right up here. It's farther away out of those two dots that are both something over 6. It's farther away. Remember, there are two dots in this quadrant that would use a 30, 60, 90 triangle. One down like this, and one on its side like this. And that's the one we've got here. 2 pi over 3. The short leg is here. The long leg is here. So the coordinates of this point are negative 1/2, positive square root of 3 over 2. Okay, so I'm going to put that negative 1/2, positive square root of 3 over 2. Okay, so let's go back now and figure out the actual answers to the problems. That's the first step for each one, is I would find out the coordinates. Now, in order to figure out what the actual value is, first thing you have to know is how the functions and their cofunctions relate to the unit circle values. In other words, we know that on the unit circle, the cosine is the x value of each point. We know that the sine is the y value of each point. Now, tangent is sine over cosine. So in this case, if sine is the y value of the point and the cosine is the x value of the point, then it's y over x. Now the cofunctions are the ones that sort of pair up with each one of these, and I'm putting them across always together with the one that they're cofunction with rather. Cosine is a cofunction with secant. Secant is the same thing as the reciprocal of the cosine. This means the reciprocal. It means flip it over. I am going to write this in big letters because it does not mean inverse. The secant is not the inverse of the cosine. It is the reciprocal of the cosine. Okay, so that means 1 over x, or just the reciprocal of whatever your x coordinate is. The sine goes with the cosecant. It's the reciprocal of the sine. So 1 over y, which means take your y value and flip it over, the reciprocal of your y coordinate. And finally, the cotangent goes with the tangent. It's the reciprocal of the tangent, or cosine on top, sine on the bottom, or x over y. So this is what we're using once we know the coordinates. All these x's and y's, they're my x and y values from the coordinates. So once I've figured out, the whole point of the unit circle is to give me those coordinates. I find the angle and I go, okay, here are the coordinates for that angle. Then I have to use this to tell me what values I'm going to use or how those values are going to work. So first one on here is cosine of 5 pi over 3. Okay, when we found our coordinates for 5 pi over 3, we said that they were 1/2 negative square root of 3 over 2. That doesn't seem right. Wait, let's see. Those should both be negative. I'm not sure why I wrote positive. This one right here, 5 pi over 3. No, it's not. I'm so sorry. It's positive. Okay. Now I'm getting myself confused. That is positive. We were good. Okay. So cosine is just the first coordinate. That's it. Okay. Next one, cosecant. Cosecant of 3 pi over 4. Well, when we figured out where that was, the coordinates of that point were negative square root of 2 over 2, positive square root of 2 over 2. Okay, cosecant, I have to know that cosecant goes with sine. It's the reciprocal of the sine. Here's the sine. So I'm going to take that and I'm going to do the reciprocal of that. That means flip it over. But we can't leave it like that. It's not rational. So I have to rationalize the denominator, and when I do that, here's what I get. I'm still not done because 2 over 2 cancels. This is my answer. Okay, next, sine of 5 pi over 6. When I found the coordinates for that point, the coordinates for the point 5 pi over 6, or the point on the unit circle at that angle, is negative square root of 3 over 2, positive 1/2. Okay, the sine is the second coordinate, so I'm done. Next, cosine of 11 pi over 6. Okay, we found the coordinates already for this one. We got square root of 3 over 2, negative 1/2. All right, cosine is the first coordinate, so it's square root of 3 over 2. Next, sine of negative pi over 2. The coordinates we found for that point, or that angle, were 0, negative 1. The sine is the second coordinate, so there it is. Next, tan of 2 pi over 3. The coordinates we found were negative 1/2 square root of 3 over 2. Now, for tan, I have to do a little calculation, because remember, tan is sine over cosine, or the y value over the x value. So I'm going to take this y value, put it on top, put the x value on the bottom. We've talked about this, that if you have the same denominator and you're dividing fractions, those denominators are going to cancel. So this is the same thing as negative square root of 3. And that's my answer. All right, this gets us to the point where I have already found the coordinates for each one. So I was just doing that ahead to show you that process. Now let's go ahead and skip to, what if I don't already have the coordinates? Let's do them both. Do both things. So secant of 11 pi over 6. Okay, I need to know where 11 pi over 6 is. I know that it's almost all the way back around. It's only 1/6 away from it. So it's closer to the x-axis, and my 30, 60, 90 triangle is turned this way, so that the long side is here and the short leg, long leg, and the short leg is here. So this is the square root of 3 over 2. This is the 1/2. The coordinates of that point are positive square root of 3 over 2, negative 1/2. Okay, so this is my first step in figuring that out. Then I say, well, secant. Secant goes with cosine. So secant is the reciprocal of the cosine. Here's the cosine. I need to flip that over. If you still have a radical in your denominator, you're not done. Now you are, and that's my answer, 2 root 3 over 3. All right, next we have sine of negative 15 pi over 4. Okay, one way to figure out this one is to find a coterminal angle. If I'm dealing in fourths, then 2 pi would be 8 of them. 8 over 4 is 2. So I could go all the way around by adding 8/4 to this. If I'm at negative 15 and I add 8, that's negative 7/4. So negative 7 pi over 4 would be coterminal with this angle. That's still negative. It'd be easier still if I add 8 over 4 again. Negative 7 plus 8 is positive 1. So this is the same as this. It's asking me the exact same thing. The coordinates of the point pi over 4, remember pi over 4 is right in the middle of the first quadrant. Everything over 4 is always square root of 2 over 2, square root of 2 over 2. The only difference might be the sign. This time, first quadrant, no difference in the sign. The sign, and by sign I mean S-I-G-N. First quadrant, both signs are positive. The sign S-I-N-E is the second coordinate. Doesn't really make a difference, but there it is. So that's my answer for sine of negative 15 pi over 4. Okay, next we have tan of 7 pi over 6. All right, 7 pi over 6. 1 pi is right over here. That's 6 over 6. 7 pi over 6 is 1/6 beyond that, so it's still close to the x-axis. So it's the long direction, the long leg is on the x-axis, and the short leg is down. So the coordinates for this point are negative square root of 3 over 2, negative 1/2. Now if I'm doing tangent, remember it's, well, running out of sine over cosine, right here it is, sine over cosine, which is your y value over your x value. So it's this one over this one. Notice that's negative over negative. It's going to cancel and be positive. The value of the tangent is positive 2 places. First quadrant, because that's positive over a positive, and third quadrant, because it's negative over a negative. So this is going to be, remember we can cancel out those common denominators. So I get positive 1 over square root of 3. I need to rationalize that, so I will do that. Times square root of 3 times square root of 3, and I will get as my answer square root of 3 over 3. All right, almost there. We only have one more left to do. Last one, cotangent of pi over 2. Pi over 2 is an easy one. It's straight up. Here's pi over 2. The coordinates are 1, 0, 1. Can't see it. There you go. That's pi over 2. Remember, this is pi, so this is half of pi, or pi over 2. So here are my coordinates. Cotangent is the reciprocal of tangent. Remember, tangent is sine over cosine. So this is cosine over sine. Let me show it to you. Cosine over sine, here's cotangent, which is the x value over the y value. So I'm going to put the x value, which is 0, over the y value. You really got to be careful about which is going to be on top on these ones where there's a 0. Because if you have 0 on top of a fraction, that means your answer is 0. I don't want to see this, I want to see 0. If you have 0 on the bottom of a fraction, you say, I can't do that, it's undefined. And that would be your answer. And that is all of the problems that you did today on this little unit circle quiz. Good luck next time.